Okay, I said it was the end of chapter 4, but I forgot about future value. So this is 4.5 future value. And I'm going to skip the warm up and just go to this formula that's really pretty. And then everybody hates it. But I will tell you, you will get the formula given to you. So that's good. And this is the formula. And all the parts are just like the parts in the other formulas. Principal is what you start with, your rate, the number of times you're compounding in time. And this is a periodic payment. And this is what's different, is all the others, we started with a given amount, and then that amount just sat there and grew interest. But in reality, when we're saving money, what we're going to do is have payments that we add in every so often, especially for like retirement. And that's the example I have here, that we're going to invest $150 each month. That's my periodic payment. Okay, so the P is my payment into a 401k, and it's expected to grow at 8.4. And remember, our rate is a decimal, so that's going to be 0.084. And we're looking at how much we're going to have after 10, 20, or 40 years. And we're going to plug all that information in. So if I start with the 10, okay, and whoops, hold on. So I'm going to have A equals 150, and then I'm going to have 1 plus 0.084 divided by 12, all of that to the 12 times 10 minus 1, and then all of that over 0.084 over 12. Okay, so after 10 years, I would have $28,062.82. Okay, and I would have invested $18,000. Okay, so that's $150 a month, 12 months for 10 years. So that's $18,000 invested. If I did the same thing, but all I did was change the 10 to a 20, so I have 150. Everything in here is going to be exactly the same, over 12, except it's 12 times 20 minus 1. That's what's going to make it for 20 years. That's going to give me $92,876.67. And I would have invested $36,000. Okay, so I'm investing twice as much, but I'm getting close to tripling the amount of money I have in my account. This is the power of investing. It's really important that you start young because it grows faster on the early end of it. If I did the same thing but with 40, I have 1 plus 0.084 over 12, all of that to the 12 times 40 minus 1. Then I would have invested $72,000 over 40 years. But the amount in my account would be $588,303.56, right? So that's almost 6 times as much as I made in 20 years, and I only doubled what I put into it. So it really makes a difference that you're consistent about putting money in over time and leaving it in there to earn money. So let's look at this. We can work this backwards, okay? Let's say I want to retire with $1 million. And we put it in an IRA, and we're going to grow at 8.6%. So that's 0.086. And I start when I'm 23, and I want to retire when I'm 65. So that's going to be 42 years. So T is 42, and my R is 0.86. And in the end, I want $1,000, or sorry, $1 million, $1,000, $1 million. So my payment is what I'm looking for. The P is what I'm looking for. So I have 1 plus 0.086 over 12, and that's to the 12 times 42, because 42 years, minus 1, all over 0.086 over 12. Okay, and if I calculate that all out, I have 1 million equals P times 4962.7. So I'm going to divide both sides by that 4962.7. And my payment would be $201.50. And that's really not that much. So if you invested just a little over $200 a month from the time you're 23 to the time you're 65 and you're consistent about it and you don't miss any payments, you will have $1 million by the time you retire. And so people ask, how do teachers retire when they don't make much money? But if you don't have to put a lot away, you just have to do it early and often, and then you can retire and do well. That's the end of my future value. And that really is the end of chapter 4 now. Thanks.